Thank you, Blessing. Thank you, Blessing. I'm recording now. Thank you very much. Consider a set of data. So you have a set of data, x1, y1, x2, y2, up to xn, yn. So we have that set of data and a simple linear regression given by yi, which is equal to the intercept plus the slope multiplied by xi plus the error term. And the errors are normally distributed with a mean 0 and a constant variance sigma squared. Now, from that population, we take a sample of size 10. We take a sample of size 10 from the population, and we feed this model. We feed this regression model, and we get our fitted model to be 2.106 minus 0.933 xi. So this is the fitted model. And you can see that our intercept there is 2.106, and our slope is negative 0.933. And we have the standard error or the standard deviation of the slope, which is S beta 1 hat 0.071. And we have SSXX, which is 1,568.625. So that is the given information. That is the given information. And remember, I told you that please don't memorize because you don't know how this information will be given. I'm still saying the same. Please don't memorize. Don't memorize. You don't know how this information will be given to you next week, Friday. Don't memorize because there's no need to ask you to calculate SSXX. You've been doing that since first year. So you cannot spend time memorizing how to get SSXX. Understand these things. Understand everything. So the first question, I don't want to preach today. The first question, if you were to draw a scatter plot, what kind of relationship would you expect? It's obvious from the fitted model that we have a linear function. We have a linear function, but we don't stop there. We don't stop there. When you fit a scatter plot, you will get that the relationship is linear, or you will get whether the direction as well, whether it's a linear or it's a positive linear relationship or a negative linear relationship, or there's no relationship. You will get those kind of things when you fit a scatter plot. So when we say what kind of relationship would you expect, it's either you get a positive linear, a negative linear, or a curvilinear, those kind of things. Now, when you look at the given information, it's only the slope that can tell you about this relationship. From the equation, we can see that the relationship is linear. So from the equation, we can see that the relationship is linear. Now we want to know the direction of this relationship because we can see that the relationship is linear from the equation. Now the direction, we are guided by the slope. So the sign of beta 1 tells us that the relationship is negative. So there's a negative linear relationship. It's simple like that. From the given information, you can get that information that if we were to draw a scatter plot, we're going to get a negative linear relationship. Strong negative, strong, perfect, whatever is not correct. You cannot use beta to measure the strength of the relationship. So people have been saying perfect because beta is close to 1. The slope is close to 1. We don't measure the strength like that. A slope can be any number. A slope can be 20. So if it's 20, it means it's perfect, perfect, perfect. That's what we are saying, because we are saying it's perfect because that is close to 1. So if it's more than 1, then it's perfect, perfect, perfect. So we don't measure We don't measure it like that. Let's do it like this, David. Let us go through these questions, then we'll open for questions, because I know you have questions. So can I please first explain, then I open for questions? I don't know. What do you think?
It's also fine, so you can proceed, then we'll ask question later.
Okay, thank you. So that's what we are going to get. And there are those who said strong negative, or they just said negative relationship, because when the values of y increases, the values of x decreases, something like that. Again, you see that from the beta. So you have to tell us that because of the beta, this is the situation. So if you don't say anything about the slope, now it is questionable whether you are copying somewhere, because you didn't capture everything. You can see that when the values of x increases, the values of y will decrease, something like that. But you get that from the slope, because you are not given a data set. So you cannot see that from a data set. You see that from the slope. So if you don't talk about the sign of the slope, then now you are cheating us. Now you are cheating us, you are guessing. Because from the given information is the slope that can help you answer this question. So the answer there is simple. There's a negative linear relationship between x and y. Simply because our regression slope is negative. You are done. So you have justified your answer. There's a linear relationship because the slope is negative. Then you are done. We go to B. You construct an ANOVA table using the given information. So B, the first part of B was to construct ANOVA. The second part was to test. Majority did not test. They did not cover the second part of the question. They did not test. They focused on the ANOVA table. So it was 4 marks for ANOVA table, 4 marks for testing. So if you didn't test and your ANOVA table is correct, it means you have 4 marks. But we are going to complete or to construct the analysis of variance. You will see. Again, I want you to copy the given values, because I'm going to project the whiteboard so that we can construct our ANOVA table. No, you have the question paper. There's no need to copy this. Just open your question paper. Let me project the whiteboard so that we can work. Can you see the whiteboard?
Yes, sir.
Thank you very much. Thank you very much. So our ANOVA table, we have a source of variation. So we have source of variation. I will just write var for the sake of this space. So I will write var, and we have degrees of freedom. We have sum of squares. We have mean square. We have the F ratio. We have the regression. So I will write reg. We have the error, and we have the total. And we have the total. The degrees of freedom for regression, it's always 1 in simple linear regression, because it's the number of parameters minus 1. So we have 2 parameters, so it's 2 minus 1, it's always 1. Then this one, it's n minus p. N is the sample size. P is the number of parameters. So we have 10 minus 2, and that is 8. The total is the sum of these two. This is going to be 9. Or you can also calculate it from the formula, which is n minus 1. So you get 9. Then we have these ones. We have these ones.
So can you repeat on the error part, please?
The degrees of freedom for the error, it's n minus p. P is the number of parameters. N is the sample size. So in simple linear regression, or the given regression equation or regression model, it's having two parameters, beta 1 and beta 0. So our n is 10. So we're going to have 10 minus 2, which is the number of parameters. And then we get our 8. Then from the given information, it's not, okay, let me not say it's not possible. It's possible, but time consuming to start with, because we have to check which value it's easy to get. So from the given information, one can start here. F is equal to t squared. And to get t squared, it means you need beta 1 hat divided by the standard error of beta 1 squared. This whole information is given. Beta 1 is given. Beta 1 is given there. It's minus 0.933. So that one is given. The standard error is given is 0.071. When you square this, you will get your F value. What do you get when you square that? What do you get when you square that? So the correct F value is 172.681 or 82 if we round this to 3 decimals. So that is the correct F value. So you are marking now, you know that your F is correct. It's correct or not correct. There are people who are having 170. I don't know how did they get their 170, because their MSR and MSE are correct, but they are mainly. So it's easy to tell that these people were writing in group or in groups because they are main. They have the other values are correct, but their F value is not correct. So I don't know what happened there. So you have this information. We know that SS reg is equal to MS reg. That one we know. And we also know that SS reg, which is equal to MS reg, is nothing but beta 1 hat squared SS XX. And this information is given. So this is minus 133 squared multiplied by, this one is also given. It's 1568.625. So you press your calculator. That one is given. That information is given. So when you press your calculator here, you'll get 1365.471, and it's the same as this value. So you have those. Now we are left with SSE, MSE, and SS total. Now, we know that our F, I will write it down here. We know that our F is nothing but MS reg divided by MSE. And if you make MSE subject of the formula from here, if you make MSE subject of the formula, it means our MSE is nothing but MSR divided by F. And our MSR is there. Now we have calculated it, divided by our F, which is 172.682. And if you press your calculator, you are going to get 7.907. To get MSE, you divide SSE by the degrees of freedom, which means when you multiply MSE with the degrees of freedom, you will get SSE. And if you multiply 8 with 7.907, you will get 63.256. Now you need the MS total. You add these two. To get the MS total, you add these two values. You add SS reg and SSE, and then you will get 1428.727. It was simple like that. And this is not the only way of constructing this ANOVA. This is not the only way. After this, I will show you. So it was simple like that, but that was not the only way of getting these values. So now let's go to the second way of getting values. So this is, yes.
When we construct this ANOVA table, do we start by stating our hypothesis first?
No, you state your hypothesis when you are testing. Remember, you first construct the ANOVA table, then you go to test. When you are testing, you will have to tell us what are you testing. We have to write the null and the alternative. I will get to that point. Let me explain something here. There are people who took this value here. It's wrong. So I've marked you wrong. And the marks are allocated as follows, before I forget. So in the ANOVA table, there's 1 mark for the degrees of freedom for the error. There's 1 mark for SSREG. SSREG and MSREG is the same, so I mark this. There's 1 mark for MSE, because MSE is very important. You also need it when you construct the ANOVA table. And there's 1 mark for F. As I've said, the ANOVA table was having 4 marks. So you can mark your ANOVA table now. You know, if these values are correct, then you have 4 marks from there. So if your values are correct, then we have 4 marks from there. Let me try another way of solving this ANOVA table. You need the MSE. You need MSE. And we know that MSE is equal to S squared. Now you are given this. And this is nothing but the square root of S squared divided by SSXX. And this tells us that, because remember the square root of A over B is the same as the square root of A over the square root of B. So we can do that here. And if we do that, it means the square root of SSXX multiplied by S beta 1 hat, it's equal to the square root of S squared. So if we square this side, we square this side, we'll get our S squared to be SSXX multiplied by S beta 1 hat squared. And then you substitute, because this one is given and this one is given. Now you substitute. You are going to have the values there, which is 1568.625 multiplied by 0.071 squared. You get the answer. So that is your MSE. And we know that MSE is nothing but SSE divided by the degrees of freedom, which is n minus 2. So when we multiply, I will take it here. When we multiply MSE by n minus 2, we get SSE. So if your MSE is correct, then you have 2 now. You have SSE and MSE. From the given information, it was easy to get SSREG. SSREG, I used the same approach. You can get SSREG. And to get SSREG, I mean, it's beta 1 squared SSXX. So this was given, you get that. Then this is equal to MSREG. So now you have MSE, SSREG. When you add those, they give you the SS total. Then you divide the MSREG with MS error, you get F. And that is not the only way, by the way. So there are a number of ways of getting this ANOVA table from the given data, but because of time, let's move. So that is the ANOVA table. Now, it was the first part of number B. The second part is to test. When you test, the first thing you do, you state the null and the alternative. You know the procedure. No, we are not testing the intercept, we are testing the slope. Please mute your mic. So you know the procedure. It's there even in the guide. When you test, you first state the null and the alternative hypothesis. You have 1 mark for that. For stating the null and the alternative, you tell us what are you testing, because you cannot just test without telling us what are you testing. You have 1 mark. Then the F calculated, you take from the ANOVA table. So if it's wrong from the ANOVA table, then this part is going to be wrong. We are not going to allocate a mark because already it is there in the ANOVA table. But there are those who did not write it in the ANOVA table, but come here and write it. So I will mark it here if it's not there in the ANOVA table. But I cannot mark it in the ANOVA table and also mark it here. And then now we want the F tabulated. The F tabulated, the degrees of freedom is 1 and 8 at 0.05. You are given the level of significance there. It means you have to find the F tabulated. So we're giving you the level of significance. It means you must get the value from the table. And that value from the table is 5.32. And there's a mark for that, reading the value from the table. Now, you decide whether you reject or fail to reject. So you can see that the F calculated is greater than the F tabulated. Then you reject H0. There's a mark for that. Then you conclude. You conclude in favor of this. What does that mean? Beta 1 is not equal to 0. Beta 1 is not equal to 0 means that there is a relationship. There is a significant relationship between X and Y at 5% level. This part is very important. If you said there's a relationship where I told you even on the first day that we are on, it was still February. I said we are in the month of celebrating love. People are celebrating their relationships, and we are not testing those relationships. We want to test the relationship between variables. So it's important when you conclude that you tell us there's a relationship between the response variable and the predictor variable. So there's a relationship between X and Y, but you are testing at 5%. It's also important because maybe at 10%, the conclusion is not going to be the same. So you must specify that at 5%, there is a relationship, there is a significant relationship between X and Y. But if X and Y, if X and Y is not there and the level of significance is not there, then the answer is not, or the statement is not complete. So please write the correct things. So there was also a mark for that. So it's 4 marks. So that is 8 marks. 4 from the ANOVA and 4 from testing. You cannot test the hypothesis without the null and the alternative. So please, there are people who decided to take this value from the T table. So they use the T table to get this. So it's wrong, because when you test the analysis, or when you test from ANOVA, we are using the F test. So you must read the value from the table, because when you give me a value, I don't just mark it wrong. I want to understand, how did you get that value? Where did you get it? Those kind of things. So I realized that people were reading from the T table, and that is not correct. So please do the right thing. So please do the right thing. Let's go back to the question paper. The second question we are saying verify the results in B using a 95% confidence interval. So you construct a 95% confidence interval. You construct a 95% confidence interval and conclude. So we want to check that if you use a 95% 95% confidence interval, will we arrive at that conclusion? That's what we want to check. That's what we want to check. And the formula for so this one is given and this one is given. What you need is the value from the table. So it's T. Our alpha is 5%. So 5% divided by 2 is 0.025. And our degrees of freedom is the one of the errors from the ANOVA table. And that is our degrees of freedom. And the value from the table is 2.306. And there's a mark for that. So if you have the correct value from the table, there's a mark for that. There's no mark for the formula because you are copying this. You are writing with your books opened. I know. So there's no mark for that. This one was given. The mistake that people made was to leave the negative there. The slope is negative, so you take it with the sign. And this one is given is 0.071. And the interval, it's minus 1.097 and 0. So again, there are people like Saulekan who don't know how to use the number line. They think this value is greater than this one. So they decided to sharpen the values. Take this one, this side, and take this one to the other side. And I marked you wrong because now it's no longer correct. If you have the upper limit on the lower and the lower on the upper, then you have mixed things. So it's wrong. Minus 1.097 is not greater than negative 0.769. So if you have a situation like this, please use a number line, then you will see. So there are people who did not put this negative and it affected these answers. There are people who are having the correct answers, but they decided to swap them because of not knowing which one is greater than the other one. So now you have this. There's a mark for having this, and there's a mark for this. The question was out of 3. Now, the last mark, you are verifying what you tested on the previous question. On the previous question, you were testing the relationship. When you use a confidence interval, how do you test? People were saying we are 95% confident that the value of beta 1 is between this. We didn't want that. We didn't want that. We wanted you to tell us whether we are rejecting or not, whether beta is equal to 0 or not. Is there a possibility that beta 1 hat is equal to 0? So if you look at this confidence interval, 0 is not part of the confidence interval, and that tells us that there is a significant relationship. You will complete. There is a significant relationship between X and Y at 5%, because when you construct a 95% confidence interval, it means our level of significance is 5%. So if you have this, again, you have another mark, now it's 3. But if you don't have this part, you just said beta is between this and this, then you did not answer the question. You did not answer the question. And again, there are people who were guessing there. The instructions were, or the question was clear. Use a 95% confidence interval. People get there, state the null and the alternative. State the null and the alternative. Sorry. This will be H1 then. Then we have H0. Beta 1 is equal to 0 versus this. They do that. From there, they calculate this. These people didn't know what they were doing. It means they were cheating. You did not use a confidence interval. We wanted a confidence interval and you used the t-test. That's not what we were looking for. Then what they did, they used the t-test. After using a t-test, they construct the confidence interval. So they provided two answers. So they don't understand how to test using a confidence interval. Then they use the t-test. After using the t-test, they use the confidence interval. They take the interpretation from the t-test, put it there. Now I have two answers there. The other one, you didn't answer the question. We said use the confidence interval, you use the t-test. It's wrong. You didn't know what you are doing. You were taking chances there. So you were on better bet. You were gambling because you didn't know which one is the right one. So you decided that you are going to provide me two answers. Can I please
Can you
finish?
repeat the
Can we?
question?
Okay, thank you. Because 0 is not part of the confidence interval. Let me project. Let me project. Oh no, I've projected the wrong one. I've projected the wrong one. It's this one. Now, if you look at our confidence interval, it does not contain 0. 0 is not part of the interval. And that tells us that there's no chance that at 5% level, beta 1 or the slope can be 0 because it's not in the interval. So if it was if it was in the interval, we're going to say a different thing now, that there is a possibility that at 5% beta can be, or the slope can be 0. So in this case, 0 is not part of the interval. So it's simple like that. Since 0 is not included in the interval, then the regression slope is not equal to 0, or there is a relationship between X and Y at 5% level of significance. Are you answered? Thank you. Now let's go to the question paper. So number D. On D, we are saying calculate and interpret the correlation coefficient. This is R. And there are people who calculated the correlation coefficient on the first question. And on the first question, I didn't ask anyone to calculate the correlation coefficient. I said if you were to draw a scatter plot, people calculated the correlation coefficient. That's wrong. So on number D, that's where we calculate the correlation coefficient. Let's go back to the whiteboard and calculate that. Let's go to the whiteboard and calculate the correlation coefficient. Now, the correlation coefficient, it's R, and the formula is beta 1. You help me here. I forgot. It's beta 1 what? I forgot this formula. I didn't use it. Let me use the one that
Beta 1, the root
it's simple.
xx over
R
xs.
is equal to, thank you, Omo. R is equal to the square root of R squared, or plus or minus the square root. So in this question, it's clear that there is, or from the first question, we know that the relationship is negative. We don't know the strength, but we know that it's negative, or it's inverse. So now it means we can choose from plus or minus to have negative square root of R squared. And R squared is nothing but SSR or SS reg divided by SS total. And these two values are there in the ANOVA table. This must be negative. So when you go to the ANOVA table and take those values, you will have 1365.471. And here you will have 0.727. And the answer there is negative 0.978. So you can even use the other procedure. It will take you to this. If you use the other procedure, it will take you to this. Homu, you were saying that formula is what? I mean, sorry, let me erase. Oh, you have 1 mark for this value. Now you have to interpret it, because the question was saying calculate and interpret. So now you have to interpret it. I provided you with some notes on Blackboard on how to interpret these values. If the value is close to 1, like this one, there is a very high correlation between X and Y. Don't say high correlation, where? So please write full or complete things. There is a high correlation between X and Y. There is a strong negative relationship. It's important to mention those things. The value is negative here and it's close to 1. It means there is a strong negative relationship between X and Y. There is a very high negative correlation between X and Y. So you interpret it like that, you get the second mark. But if you say
You said two different things, sir. Can you give us like the one that is actually needed?
No, they are both correct. There is a strong negative relationship. There is a strong negative relationship. We are measuring the strength. So there's a strong negative. And one might decide to say, no, I want to use the word correlation. Then there is a very high. If you follow the table that is on Blackboard, you will see that if the value is close to 1, we are saying there is a very high. But now you have to decide in terms of the direction now. Now, this one is negative, so there's a very high negative correlation between X and Y. So if you said there's a strong negative relationship, it's correct. If there is a very high negative correlation, it's still correct. Are you answered?
Yes, sir.
Thank you. So that is the value. I was saying that you can also get it from using the formula, and that formula I think is beta 1 at the square root of what? Is it SSXX divided by what?
SSYY.
SSXX divided by SSYY. This one is given. It's minus 0.933. The square root of. This one is also given. It's, what is that value? What is that value? It's 1568.625 divided by SSYY is nothing but SS total. So from the ANOVA table, you can get your SS total. You can get the SS total from the ANOVA table, 7, sorry. And this will give you same value. And then we go to, it's only one person who got this +2 correct. Because number F
May I
was
please go
depending
back,
on
sir,
number A.
to the slide?
Number E, I mean number F was depending on number E. So there's only one person who got number E and number F. The rest you got 1 from number E, or you got 0 from number E, but the majority got 1 from E, and then the rest got nothing. Or majority did not answer. I think majority did not answer this question, and it was the simplest, but majority did not. I'm referring to those who wrote the quiz. They did not answer this, and from those who answered it, majority got 1. So I want that to be clear. Majority of those who answered it got 1 from the question, and it was the simplest of them all. Let's go to that question. Please mute your mic. Please mute your mic. Now, we want to find the variance of W and W is equal to this expression here. So I'm going to find the variance of W for you. I'm going to find that one for you. So let's go back to the whiteboard. So I will write W first here. Our W is nothing but the summation. I will recognize you when I'm done. Please let me allow me, unless there's something from the previous question. But if it's a question related to this, please allow me to finish. And then yi. It's yi. This part is a constant, as you can see. This part is a constant. This part is a constant. And we know that the variance of ya or ay is a squared, the variance of, and the variance of, okay, the variance of summation of is equal to a squared summation, summation, the variance of y. So we are going to apply that here, which means the variance of W is going to be, we are applying this, is going to be, this is a constant, so we are squaring it. It's going to be our a squared. So we're going to square this constant. SS x, the variance of y. So for knowing that definition, you get 1 mark. So for knowing that definition, you get 1 mark. This one must be squared because it's the constant squared. For knowing that definition, you get 1 mark. So the majority that got 1 is because of that. They know the definition of a variance. From here, we can substitute. We know that the variance of yi is sigma squared. And sigma squared is constant. So if it's constant, you can take it out here. And then you have the summation of, and people stopped here. Just for 3 marks, you stop here. And you expect to get 3 full marks. Just to write this. You have 1. If you stopped here, you have 1 mark. If you stopped there, then it's 1 mark. Then from here, we have to simplify this comrade here. And when we do that, I will write it like this. This is nothing but a plus b all squared. And that we know that is a squared plus 2ab plus b squared. So this is our a. It means we're going to have 1 over 10 squared, 1 over 10 squared plus 2ab. So it's going to be 2 multiplied by 10, and that will be 1 over 5 multiplied by xi minus xx plus our b squared. Our b squared is this term is going to be xi minus x bar squared divided by ss xx squared. We have that. Let me create a space here, up here. So we have that. Now we want to bring in the summation. Now we want to bring in the summation. We have, let's say, sigma squared into, this is sum from 0 to 10. When you sum a constant n times, it becomes n multiplied by a constant. So here we're going to sum, yes.
Before you continue, can you please explain that step again?
Now here we have a plus b squared. And by that definition that we have been using since primary is that a plus b squared is nothing but a squared plus 2ab plus b squared. So if this is our a, it means here we're going to have a squared if we're following this definition. So a squared is going to be 1 over 10 squared. 2ab, it means we'll have 2 multiplied by 1 over 10 multiplied by xi minus x bar divided by ssxx. So 2 multiplied by 10 or 1 over 10 will give us 1 over 5. And then our b will remain, which is xi minus x bar divided by ssxx plus b squared. B squared is this part. So when you square this part, it's remember, a over b squared is the same as a squared divided by b squared. So that's what we have done here to separate that squared. So we have this. So this is the step. I'm not sure if you answered now.
Yes, thank you.
Thank you. So now we are bringing in the summation. We sum the constant 10 times. It's going to be 10 multiplied by the constant. So that 10 is going to cancel 1 there, and we'll be left with 1 over 10. Is that one clear?
No, sir.
1 over 10 squared, it's nothing but 1 over 100. So if you sum 1 over 100 10 times, it means you are going to have 10 multiplied by 1 over 100, and that will give you 1 over 10. So this one will give us this. Now you take in the summation to the second term. The constant, we take it out, we sum this. What is the summation of the numerator is 0, because it's the sum of the deviation. The sum of xi minus x bar is equal to 0. So this part will disappear because it's 0. Now you sum the last part. When you sum the last part, now the numerator, because of the summation, the numerator becomes ssxx, and the denominator is still ssxx squared. So this will cancel 1 in the denominator, and you'll be left with 1 over ssxx. And that is the final answer. You have...
Sir, can you repeat the second term?
Okay, I will do that. Let me do it here so that you can understand. The second term, I will use a different color. A second term is the summation of 1 over 5 xi minus x bar ssxx. So 1 over 5 is a constant. We take it out. And also that one is a constant, by the way, ssxx. So we are taking that part out. We are going to have 1 over 5 ssxx. This is 5, not s. Then summation of this. And this we know it's equal to 0. We even proved it on our first day. This is equal to 0, we know. So we substitute this by 0. It's going to affect this whole thing, and this becomes 0. Are you answered?
Yeah.
Thank you. So it was 1 mark for this definition, 1 mark for this, and the last mark for the correct answer. And there's someone who's having an answer which is very close to this, but here is still having 100. So I didn't rob you. I checked it, and I noticed your mistakes. So you didn't deserve that mark. There's only one person who's having the correct answer. Only one who's having this answer. And this was simple. This was simple. This was simple. So please go and practice this. If we don't change, the test is having 3. Now I'm giving the scope. The test, test 1 is having 3 questions. Question 1, 2, 3. Question 1, 16 marks. I'm not going to call them proofs because I didn't ask you to prove. You are deriving things there for 16 marks. So if you cannot derive a simple things like this, then it's a problem. So please understand these things, because out of 50 or 55, then 16 marks is too much. So please go and understand these things. I'm not going to repeat anything. I told you, I'm on record, I'm repeating this. Go and understand. Don't memorize these things. Please mute your mic. So you have that 3 marks from this question. We go to the last question. The last question is simple. You have to calculate the value of, sorry, I've projected the wrong things. You have to find the value of W, or the variance of W, if the variance of the error is equal to 9. So the variance of the error is 9, it means the variance of Y is also 9, or YI is also 9. So if the variance of the errors is 9, then the variance of YI is also 9. Then now we can go to that formula and substitute. We can go to, what's it? We can go to the formula and substitute, because the variance of W is sigma squared 1/10 plus 1/SSXX. And this is 9, sorry, 1/10. This one is given 1568.625. And the answer is 0.906. There's one person who got this one right as well. And the highest got 16 out of 20. I think there are 2 or 3 who got 16 out of 20. And they got almost everything right, by the way. The person who got 16 did not get this last 2. Only got here. The person who got 16, or the people, because there are 2 or 3, it's because they did not get this one right. They got 1 from number F. So they failed to simplify. So they lost 4 marks because of that, and they got 16 out of 20. So the quiz was simple like that. You spent time doing unnecessary things. You spent time doing unnecessary things. The first person to submit, I think, took less than 30 minutes to finish writing, and that lady, I think she passed. She took less than 30 minutes to write and scan, because if you knew what you were doing, it was simple. If you knew what you were doing, I know that people did not finish because they were discussing. That's why their answers are the same and they are wrong. So they were discussing. And if you am writing this, you have to wait for someone to write and then consult, then it's going to consume time. So it was simple, but you spent more time doing unnecessary things. I think I can take questions.
Kombe kumveka last page nakopanya.
Tuto.
Sir, on the ANOVA
Yes.
table,
Yes.
on the column of the variation, where we write regression, error, and tutor. So
Yes.
if I wrote SSR, SSE, and SST.
You wrote SS. No, I don't mark that column. I don't mark that column of variation. As long as it's clear that the first row is regression, the second one is error, the last one is the total, then it's fine. But
Okay.
if the values, if you swapped the values, like I'm saying, that there are people who took the MSE to the total, to make it MST, for example, MS total. I make it wrong because you didn't write it in the right place. That value was supposed to be the MSE. Now you are telling me that is the MS. It's the MS total. So I cannot make you. I cannot just close my eyes and assume that you understand what we are doing. So are you answered? So
Yes, thank you.
don't memorize. Don't cram the proofs. Mabunda, don't memorize this. I'm not going to repeat those proofs as well, but the procedure is the same. You must know, why are we doing this? Why are we doing that? You guys complained on the first day when I gave you the first tutorial questions. You complain that those questions are difficult because you don't want to understand. Just imagine complaining about the tutorial questions. Now we have to write an assessment. You are complaining
Hey,
about
kombela
tutorial
second
questions.
chance nyana. Ish.
Sir,
There is a hand by, let me first recognize, there was a hand by, no, not you, Christopher. There was a hand, yes, Haugen.
Sir,
Yes.
honey, beta 1 head is not equal to what SSXY over SSXX.
Beta 1, let's go back. It's correct what you're saying, but I want to write it down. What's happening? Oh, Christopher, I will recognize you. Let me finish with Haugen. I will recognize you. Beta 1 head, it's equal to SSXY divided by SSXX. This is correct.
Yeah, because I used it to calculate what. Let me check. Okay.
You can use it to calculate to get this. Then from there you use this to calculate the other things. It's still correct. Like I said, that there are a number of ways, just that we can't cover all those ways here because of time.
Oh, all right.
Yes, but as long as it must give you the same answer that we got. If you didn't get the same answer, something is not right. You have to trace your steps.
Yeah.
Yes, trace your steps. You will see your mistake. There is someone, or not only one. I don't know, because you are writing in groups. I don't know whether it's one and you copied from that person. That person said MSE is equal to S beta 1 head squared. I have maybe 6 people who did this, and this is not correct. So you have to trace your steps. You will see. I didn't rob you. Rob you. So you will see when I open for the marks. You will see. Christopher, followed by Manyama.
sir, on the ANOVA table,
Yes.
I wrote my hypothesis first, and then after that
No, it's not. It's fine. As long as it's there, I will mark it. As long as it's on the right question. If it's on B, then you cannot, on C, you cannot expect me to go to C and mark it there. But if it's on B, I will mark it. But if you wrote the null and the alternative on number B, for example, then I'm not going to mark it. But if you wrote it on number B, I will mark it because the question was about testing as well. Manyama, you are recognized.
Sir,
Yes.
can I find you at your office?
No, I'm not at TEF. I'm not at TEF. Like I said, when we're starting that, we are busy with registration.
Okay,
so
sir.
I'm somewhere around Vila Vila.
Sir,
yes.
Regarding on F, on F,
yes.
I scanned everything and my result is the same as yours. But because when I was scanning, I don't know, maybe I cast some potion, a little potion. What?
Yes, I understand. You are not the only one. You are not the only one who did that. The assumption there, I thought maybe because time was not against you, was against you, and you didn't have time to go through your work to check if you captured everything. So you are not alone. There are people, like I said that day, because I created a session, so I was online. I told people that when you submit, make sure that we have combined. There are people who submitted only the first question, and it's a mistake. It happens, but I cannot assist you when you have committed that kind of a mistake. I cannot assist you. I get what you are saying, Manyama, but I cannot mark it. It's not there. You understand? So let's hope that on the next one you will avoid those things.
But according to
yes,
for the assumption, how do I arrive to the correct answer? Say,
because no, I wanted to cover that one as Listen. I wanted to cover that as well, that I don't mark because your final answer is correct. There are people who, for example, said, we reject the null hypothesis. Their F calculated it's not correct. I don't give you a mark for saying we reject the null hypothesis. Yes, we are rejecting the null hypothesis, but you must be having the correct values. So if you get to that question and say, we reject the null hypothesis, based on what? You understand? That's why you have to say the F calculated is greater than the F tabulated, we reject. We are using those. So based on that, those two values. But if your values are wrong and you say we reject, no, it's not correct because your values are not correct. So don't worry, Manyama, if there is something that we have to discuss after I have opened for the maths, then we'll make a plan. Tomorrow I'm coming back, then we'll take it from there. We'll discuss it. But let's wait until you see the math, because like I said, I was following everything. I'm not just saying answer yes correct, then I'm happy, or it's wrong, I'm happy. I want to understand. That's why I can tell you the mistakes that people have made, is because I follow up what was happening. I check what was happening.
At least if you just you could just go through
Kuto.
the steps.
Kuto, you're welcome.
Yes, sir. I would like to ask a more of a general question in linear regression. If our regression line, maybe our B0 or our B1 is 0, does that affect the degrees of freedom?
Yes, it affects the degrees of freedom. It means you will be given a model with, let's say beta 1 is 0. Then your model now is going to be yi is equal to beta 0. So you only have one parameter there. If, for example, in the first tutorial questions, I think I gave you a model with beta 1 xi. And there's a question where I said, write the variance or the formula for estimating the variance of the errors. It was going to be s squared, but it will be SSE divided by n minus 1. It's not going to be n minus 2 because you only have one parameter there. So it's those kind of things. So if you have one parameter, then it will affect the degrees of freedom.
All right, thank you, sir.
You're welcome. We're left with 20 minutes, so I can go to the next section. I explain it, then we'll do the example, because I think I need about 15 minutes to explain what we are going to do. Then we'll do the example in the afternoon. And then after that, we'll look at lack of fit. Then it will be the last section of what chapter is this? Chapter 2. And Mr. Maleka will take over from there. So if I can manage to finish today, then Mr. Malek is taking over next week. Can I project the notes, or you have something that you want to know? Yes, Kilibun?
Sir, you were saying something that scopes a testimony.
It's chapter 1 and 2. Everything on chapter 1 and 2. And I said the test is out of 55. The first, or question 1, it's 20 marks. And from the 20 marks, 4 marks is theory, 16 marks you are driving or proving how. I don't know how you will see it. Some will say they were proving, because if for example I say find the variance of y, I already know the variance of y, you already know, but there are people who are not here. If I say prove that this is equal to this, like I did with the quiz, the initial question was sure that the variance of w is equal to this, but I realized that people are going to force it. Even if it's not correct, they are going to write the final answer. like, because I have given them that the final answer is like this. So to avoid people forcing things, I will just say find the variance of W. I know the final answer. So instead of saying prove, because I don't want you to cook, then it's like that.
For question 2, Rona, Respecter.
It's application, and then from chapter 1, then the last question is from chapter 2.
Okay. Will there be any special quiz for those who have problems?
I will say something when we're left with 7 minutes. I've been saying 20 minutes. We didn't take a break today, so we're left with 7 minutes. So it's fine. I'm not going to teach. I will teach in the afternoon. I will make sure that I cover this, because we have to do the Western in the afternoon and the lack of feed. So the
test is still venue based.
Come again?
Is the test still venue based?
Yeah.